Winter, cold, and snow. Those are the three magic words that, when said this time of year, instantly capture people's attention and imagination. And they have been said a lot in recent days and weeks. They've been said by me and many others in the weather community as we leave the fall season and head toward the holiday season and toward our first month of winter. Of course, that's December. And as I've said before on this channel, there are indications that December and winter may get off to a fast start. Well, part of that's true. December will arrive at the regular speed, but winter may indeed pick up the pace and hasten to bring cold and snow to many in the United States as we turn the page on the next month. And so we're going to look at some of those reasons why that might be the case in today's video. I'll have a little bit at the end about the forecast over the next couple of days as we head to the weekend. Not a lot going on, but I'll show you what is going on. And then we've got to look at space as well, because we've had some big time solar storm activity. I'll take a look at sort of the wrap up on that as well and see what might lie ahead. But in the meantime, we've got to get into some things that affect winter. And those are things like the MJO, the Stratosphere, La Nina, and several other things, some of the indexes that we commonly talk about, the EPO, the PNA, the NAO, and so many more other things. So we're going to get into all of that right now in today's video. Friends, if you haven't yet joined the team, hit the subscribe button right down below and sign on. It's free, it's easy, and it's one of the primary ways that YouTube helps channels like this to grow. Give the content a like, leave a comment in the comment section. If there's any questions that you have, please put them in there. I read and respond to all of those comments. Most importantly, leave a prayer request if there's anything I can support you through and pray about. So please do that. Let me know where you're commenting from too. But with that said, we're going to go ahead and jump in here. What the heck am I looking at? Well, we're not looking at this yet. This is a little bit too early. We'll get to this in a second. But what are we looking at here? A big blank white screen. Let's go here, and now we can see it. Ah, yes, this is our friend, the MJO. You hear a lot of people talking about this. I'll talk about it too. I'm going to tell you what it is and why it matters, okay? So those are the things that you always want to know. What is it? And why does it matter, okay? So that's what we're going to get into today. We've got a lot of tabs to get through, but I'm not going to meander around on every single point, but I want you to understand this. The MJO, the Madden-Julian Oscillation, that's what it stands for, is an area of convection that circles the globe near the equator, and it goes around and around and around, and sometimes it gets stronger and sometimes it gets weaker. And why does that matter? Well, I'll tell you that in just a second, but just know that convection, of course, if you don't know, it's just a fancy meteorological word for thunderstorms. It's a cluster of thunderstorms, and when it goes around the globe, where it is and how strong it is and how weak it is influences or can influence weather patterns. It doesn't live in isolation. There are other things that influence too, but the MJO can influence the jet stream and change the weather where you are depending on where it is. And here's how that is represented. Instead of just showing you a big globe and spinning the globe around and trying to paint convection on it, the representation is in this funny looking graph. You have a circle in the middle and you have all of these quadrants that are broken. It's not really quadrants. They're broken out into sections: 1, 2, 3, 4, 5, 6, 7, and 8. These are the phases. We call these phases of the MJO. And the black line is where it's been, the red line is where it's going in the next week or so, and then the blue and the purple is where it goes out in time. This is what the model is projecting, and all of the different models project this. I'm showing you the European extended representation. This is basically the Euro monthly representation of the MJO. All of these yellow lines, the European monthly is an ensemble suite that is made up of a lot of different members, and then they average it out, and that's why they you see this one line here, that's the average or the mean of all the members, and all of these yellow lines gives you the individual members drawn on here, and it gives you an idea of what the spread looks like. If it's spread way out all over the page, it means there's no idea, there's no confidence in this. And if it's tightly clustered, which they are here initially, usually, you get to see you have more confidence in it. In any event, this is the representation of the MJO, and you can see that it is in phase 6. It is likely, very likely, to go into phase 7 after kind of dancing around here in on this, between phase 6 and 7, and then potentially go into phase 8. And then after that, we'll see where it goes. The model wants to hook it back into the circle of death, meaning it kills the convective pulse and they die out, and then we'll resurface again somewhere else. But that's the model representation. That's what this chart shows. And these different phases affect the weather patterns. There's a correlation to things like troughs and ridges in the United States and other places too, but we mainly care about the United States today on this channel. So that's what that is showing there, where the MJO is likely to go. Quick insert here. I got through the whole show and realized I didn't even show you this map that I started with. I meant to show you this. This is posted on our southernweather.com website, and it's posted by Eric Webb, who is very good at analyzing all of these different maps and got a lot of resources. He's a good follow on X as well. But anyway, he posted this. It's a good representation of the MJO pulse. Here's what I want you to do. I want you to imagine this blue area that you see here is that big blob of convection. Okay, it kind of moves around the equator. It's hard to see these lines, but this is the United States. This is South America, North America, South America. This is Africa here, Asia, and this is also Asia over here, and parts of there's Australia, Antarctica down here. So this blue area represents rising motion. Okay, so this is where you see rising motion. The pink area is sinking motion. This is associated with thunderstorms. So here's how it goes. Phase 1, Phase 2, Phase 3, Phase 4, 5, 6, 7, and 8. So when it's over here in South America toward Africa, that is where we're looking at, as it rotates around the globe, that's where we're looking at it being in the best position to help it be colder in the eastern portion of the country or much of North America. 5 and 6, and so then we get 7, 8, and it comes back around the globe again on this side. 1 and 2, where when it's over here in the maritime continent and over here in the eastern, or sorry, way over here in the western Pacific, back over here, this is not the best area for it to be in, and usually brings warmer weather to much of the east. And so this is just a good representation of the different phases and how it correlates. So hope that helps a little bit. Now back to your regularly scheduled program. Here is a representation of the different phases, and you can see the blues have a correlation to cool weather, the reds and oranges have a correlation to warmer weather. And so when you see phase 1, for example, when the MJO is in phase 1, much of the nation is cool in the north. This is for December or November, January, and let's do this right. November, December, and January. This is phase 1. Phase 2 gets a little bit warmer up here in the plains and the Midwest and cooler along the West Coast. Phase 3 starts to get warm for everybody. Phase 4 is a blowtorch. Phase 5 is a blowtorch outside of the desert Southwest. Phase 6 is a blowtorch. And then we start getting cool again in phase 7 and phase 8. That's why we talk about phase 1, 2, 7, and 8. Those are typically the cooler phases as we get into wintertime. And so that's where we want to see the MJO spend the bulk of its time to give us the best chance of it influencing the pattern in our favor if we're winter weather fans. Okay, so you understand that? Good. All right. So now that is that. Now, what is this? This is, I'm going to move off the MJO for a minute. Here's what we want to see here. I want to show you the cryosphere. The cryosphere is the North Pole area, Siberia over into Canada, where the snowpack has fallen. Now that we understand kind of what the MJO is and where we think it might go over the next 30 days as we get into December, into phase 6 or phase 7 and potentially phase 8, bringing cooler weather in, we have to understand what's going on up north. Are we building a snowpack so that when that cold air starts to come down, it can stay cold and stay refrigerated, or not? So here we go. Look at this. This is the daily departure. We are negative. We're running behind schedule here. That's what these red colors show up here in Canada. And over here in Siberia, looking at, or not in Siberia, this is over in parts of Europe, and up here in this area here, Siberia is over in this area, and it's normal. Parts of, I would call this West Asia, is looking not very great in terms of the snowfall department, but back here farther south, we're seeing more of that snowfall, and up here in eastern Canada. What we want to see is starting to see these reds replaced by blues, and eventually over time that may be the case as we take a look at what's going on here. Here is the current map of snow and ice. Yellow is ice, and there is your snow map, okay? So there's lots of snow up here, but it's a little bit behind schedule, and you can see this big blank area. A lot of our cool weather comes across the pole right in this area, and we need it to travel over snowpack, and we don't have a lot of snowpack there, so it's going to moderate fairly quickly, but it's still early in the season, so we're not going to be too worried about that. Now, what I'm going to show you is another thing that we look at called the stratosphere. We know the MJO, we know about the cryosphere. Now we want to talk about the stratosphere. Why does that matter? Well, the stratosphere matters because of this reason here. In the wintertime, the stratospheric polar vortex. We hear about the polar vortex a lot, okay? The polar vortex is something that intrudes into the United States, and we think of it bringing cold air in our neck of the woods. Well, way up above the Arctic Circle, circling the globe, is the stratosphere. Let me do it this way, that way you can see it. Is the stratospheric polar vortex. This strengthens in the winter due to temperature gradients, pressure patterns, and it weakens in the summer. But as we get into winter, this starts to strengthen. And if it remains very strong, stronger than normal, very strong through the wintertime, it sort of connects to the layer of the atmosphere that we live in, the troposphere, and it keeps the jet stream fairly tight and circulating, and it doesn't meander around a lot, and it keeps all the cold air kind of bottled up north. So do we want a strong polar vortex if we're winter fans in the stratosphere? No, we don't. We want it weaker than normal. That way it's easier to connect to the troposphere and displace the jet stream and allow cool air to come farther and farther south and potentially create some buckles to create storminess as well. So that's what we're looking at. This is the, let's see what we're looking at right here. This is the 550 millibar chart of the European ensemble. So this is pretty high up off the ground, but not at the top of the stratosphere, okay? So this is in sort of the middle to lower part of the stratosphere. And these red colors indicate warming. And when you get warming, that is an impulse that disturbs the stratosphere and helps it to weaken. So look at this big warm blob just build as we go on out over the next couple of weeks here. Look at that. You get this big warm blob disturbing the stratosphere and kind of knocking it off kilter a little bit. And that is a good sign as we head toward December. Okay, so there's the 50 millibar temperature. What about way up high? Does it propagate all the way up through the stratosphere? Well, here's the temperatures at 10 millibars, and my phone wants to go off, so I'm just going to throw it away. There are the temperatures. I showed you the anomaly before, how much above or below normal. Here's the actual temperatures at 10 millibars. And look at this big blob here. This is warm, warm, warm. Very warm temperatures for that particular level in the atmosphere. And you can see it just gets warm and stays warm and really just continues to warm up big time as we get on out here toward the next 2 weeks. At the end of the 2-week period, got a big arc of warm up at 10 millibars. But how is that relative to normal? Well, let's take a look. Is it warmer than normal or is it not? And it looks like it is. Look at all those bright reds. That's warmer than normal. You got some blues here too, but this is what we're interested in, this big blob of red. And you can see it just continues to pound the stratosphere and keep it weak, and this will help to disturb it and make those winds not so strong. And sometimes you even get a wind reversal there, and that's a big stratospheric warming event. And this is one of the earliest ones of these we've seen. So this is a big warming event that's going on. It's projected to really weaken the stratospheric vortex that will enable cold air to potentially come out of Canada more readily instead of being tightly wound up and trapped up there. And so that's what we're looking at. And as it turns out, this is working through the entirety of the stratosphere. Sometimes these events really just get down here and only affect the bottom of the stratosphere and all of that stuff. So this one is pretty much through the entire layer, and that's good because that'll keep it weak. And if we see another one of these later in the winter, well, that's pretty good news as well. Check this one out here. This is, let me get on a better view here. I'm trying to figure out the right one for this. There we go. This will work. This is the European monthly stratospheric vortex projection, okay? The big thick red line is the normal strength of the vortex in the stratosphere, and this blue line down here is the projected mean of the ensemble run over the next month. All the way through December, it projects it to get really, really weak and only slowly rebound toward normal as we get on into December. And of course, all these little blue lines are the different members, but the mean runs it well south of the normal strength line, so it's going to be weaker. That is good news again, as in terms of how we get we could potentially get into weather, winter weather, as we get on in toward December. So this is keeping it weak all the way through December, which is great. And we'll see what happens after that. But right now, we're going to take a look at something a little bit more familiar. If you watch this channel, we see much more in the way of these height anomaly maps. And this is the European monthly height anomaly map, okay? So we're going to move off the stratosphere. We talked about the MGO, we talked about the cryosphere, now we talked about the stratosphere. Three things. The cryosphere is not quite favorable yet, but the MGO is projected to get favorable. The stratosphere is projected to get favorable as we get into December and through the month. And now let's see what the actual height patterns look like as the European ensemble sees them as we get on in the monthly forecast as we get toward into the end of November. This is the 28th and 29th, and we've got this big ridge going up way up here in the Arctic. Why does that matter? Well, this is called what's called an EPO ridge, and this domain up here, this space, is what we look at, and you'll hear this a lot in the wintertime here. The EPO, is it negative or positive? And that's what it's talking about, this domain up here. The PNA is along the west coast. This is the Pacific North American pattern, and the NAO space is right in here in this area, the North Atlantic Oscillation. And so what we want, if you're a winter weather lover, is the EPO to be negative, the NAO to be negative, and the PNA to be positive. And why does that matter? Well, here's why it matters, okay? I'm going to delete all of that off and show you. When the EPO is negative, you've got this big ridge right here. This red color is a ridge, and you can see these height lines coming out. This air flows from this direction this way. You see that? If it's negative, that means you've got air coming out of the Arctic Circle, even potentially over Siberia with cross-polar flow coming across the pole from Siberia. That is very, very cold. That is a cold signal for air or for temperature anomalies in Canada and for the United States when you have a negative EPO. But that's not all you need. Sometimes this EPO ridge will keep the cold down in Canada, but then you've got a trough out west that keeps the west cool and bridging across the United States. You're kind of seeing a reflection of that here. The PNA doesn't look to be positive. It looks kind of negative here, or maybe even neutral. A big positive PNA is when you get a big ridge out here, and then air can just kind of flow into the east like this, okay, into the south as well. And then, of course, the NAO up here is blocking and it slows the storm track down. So you get these big bright colors up here in Greenland and southeastern Canada. It can slow the storm track down and keep the cold air bottled up in the eastern United States, producing some big-time snowstorms. If it's too strong, it'll push everything into the south, but you want this to push the jet stream south. And so those are our favorite parameters when they all line up. But if we run this out, so we've got an EPO that's starting to build as we get on into December, and then as we keep going, that EPO signal kind of stays there, it flattens out a bit, and we get a little bit of a more ridging signal on the west coast, a little troughing up north, so I would expect cool temperatures to the north, normal in the south, and cool along the north, and then into the west, warming up. Then we get blocking signal here in Greenland, so that'll keep the storm track to the south if that's real. And then we get another EPO kind of signal set up here over Alaska, and see those streamlines coming in, or the height lines coming right out of the north, seeding Canada with cold air. And so no big ridging signal here across the United States. Looks sort of like a zonal flow, but my suspicion is that's just the mean, all of the ensemble members kind of smoothing out with time. We'll definitely see some storms in here, but if we get a signal for an EPO, that means we're going to load Canada with cold air more than likely, and it just takes a little bit of ridging to pop, send all that cold air south into the eastern United States. Okay, here's the projection of the temperatures as we go on out in time. These are 5-day averages, and as we get on out toward November, look at this, warming up for much of the east in November. Will eventually cool down in the west, and then over time, as we get on into the first, second week of December, look at this, cool anomalies just intrude from Canada over into the eastern United States, across the Great Lakes, up into the Northeast. Those are the biggest signals for cool. Warm up here in Canada, there may be a signal for a ridge here, which would be NAO, which would be good, negative NAO up there. But in any event, there are your signals for cool air, a little bit more mild across the south, southern tier, but that's a pretty good run of the Euro weeklies, if you ask me. And here's the European weekly precipitation anomalies. These are, again, averages, 7-day averages as we go out here. So you can see an active storm track, plenty of rain out west. You get a little bit of a ridge response here in the central portion of the country, and then storms moving through the east, bringing rain out here. This is what the European monthlies are showing. So it's the latest run of those, and so it keeps it kind of wet here in the Dixie area and southern Mississippi Valley and that kind of thing, and maybe up and down the East Coast you get a little bit of extra rain as well. So fairly active pattern is what the European monthly is showing. There's the snowfall projection. All right, so there it is, and you got a signal for snow at some point. This is through the end of December, from today through the end of December, and look at that, snow as far south as Dallas, Texas. You know, not a big signal for a big snowstorm, but certainly some of the ensemble members are seeing that cold air coming in. Your biggest snows are, of course, up in Canada and across the northern tier. If we take a look at the CFS, this is the American model, we can kind of run it ahead too, and there's a big EPO ridge going up. One thing you don't want to see is this turn into a big block up here and sort of close off and send the cold air back this way, and you get a big trough response like that in the west. That would keep you guys cool out west. Of course, that's what you're rooting for, then you're rooting for that. But this sort of shows that a bit. But look at those cool anomalies build as we go on in toward the end of, this is the first week of December, and then we get cool in the east. Look at that big troughing signal in the east, and that would be where your storm track is, kind of like running along the central portion of the country, right along in there. EPO ridge continuing to build. Look at those anomalies up here, and just the air flowing right into Canada, so that's good. Cross-polar flow is showing up here nicely, and we get on out toward the end of December, things break down a bit, but you get a big blocking ridge coming back in, and another EPO ridge going up out here over Alaska. That is the CFS model. And so what does it show from a temperature standpoint? Well, we get on out toward the end of November. It's actually cooling us off a bit in terms of its projection, so it's a little bit cooler than the European ensemble mean or the monthly mean. And there it comes, that big cool down as we get into the first week of December, second week of December, and then things back off again and reloads again in the east as we get toward Christmas time. Wouldn't that be nice to get some cool air in here toward Christmas time? And in terms of precipitation as well, it sort of signals what the European did and keeps portions of the east above normal, the Pacific Northwest, West Coast, with more storms coming in there, keeping it above normal too. So quite a big signal for above normal precipitation here in the east and also out in the west. That's interesting. And then finally, this is the Canadian model, just the monthly average for December. It looks kind of like La Nina, doesn't it? Dry across the south or cool across the south. Wrong. This is warm across the south. I'm saying it completely backwards. Warm across the south and cool across the north. You see that? Those are the anomalies for the month of December. It looks quite La Nina-ish if you go just by Climo, but my suspicion is we'll see those poke in from time to time through the southern United States too. And the last couple of charts here I want to show are just the 2-week out normal European, Canadian, and GFS ensembles, and you can see this as we run this over the next 2 weeks. We'll start here, get into the weekend, get into next week, and then head on through next week. Warm air intruding, ridging out into the central and eastern portion of the country, with the exception of the northeast. Very, very cool out west under this trough that's coming in another storm system. But look at this big block here over Greenland. That's what the European ensemble is showing. And it's not until we get way on out here in time. This is the end of November now, Tuesday, November the 25th. You get a big EPO ridge going up like the monthly was showing. That's good. And then it sort of establishes itself and you get cross-polar flow. Start to get cool air into Canada. It's still got the signal for ridging on the east according to the European ensemble, but we'll deal with that later on. Let's just get cold air in Canada first. There is your total temperature anomaly. Let's run this back so we can kind of see how that plays out. We get on here November the 15th, 16th, 17th. Look at this big cool troughing, that signal that you get on here toward next Monday over across the northeast, some damming down the Appalachians. And then we warm up nicely according to the European ensemble as we head on in toward 24th and 25th of November. But look at that EPO ridge up here keeping you guys warm, but sending the cool anomalies down into Canada and the western United States. That's good news. There's your snowfall, building that snowpack. We need more snow here in western Canada, but the snowfall projections look to be pretty good along the up here in Canadian, some of these northern provinces over in eastern Canada. The GFS, it kind of does the same thing. We sort of see the same sort of scenario play out, warm in the east as we get on in toward the 21st, 22nd, 23rd of November. And then we get that big EPO ridge going up and we start to lose those anomalies, those warm anomalies in the east, and some of that cooler air starts to begin to filter in. This is putting us out toward the end of November the 29th here to be exact. And then finally, taking a look at the temperature pattern there, you can see the temperatures on the GFS here itself. And so there they go. Boom, there's cool temperatures. And I'm sorry, go back to that. Cool temperatures start to invade the country from the west to the east. There's the GFS snowpack, sort of similar to the European. Not much snow out here where we really want to get it built up. And but we are seeing some snow build up in the east and the very, very west. And finally, the Canadian ensembles over the next couple of weeks. This is what you really want to see. I'm going to run this along and skip ahead. Next week or so looks normal. looks in step with the European and GFS. We see that big anomaly, that cool anomaly here in the northeast. I'm showing you the hemispheric view so you can see the whole thing. And here's the United States down here. There's the warm air in the middle of the country, and PNA negative. This is a negative PNA. When you have this trough in the west, you see that down there. And watch what happens though as we get on out toward Friday and Saturday, the 21st to 22nd, 23rd. Look what happens up here. Boom, big EPO ridge pops up. You start to get cool anomaly down here, troughing in the west. Look what happens as we get on out. This thing really starts to build up and send all of that cool air out of Siberia across the pole and deposit it right here in the center portion of the country as we get on out towards Saturday the 29th. Here are those anomalies, cool in the east, warm in the center portion of the country, cool in the east as we get on out to Monday and Tuesday of next week, cool out in the desert southwest, and then warm for much of the nation through 21st, 22nd, 23rd, but it's cooling down out west, and you can see that cold air really start to pop on the Canadian ensemble. So that's the one we're hoping that it will be right as we go on out in time. But much of the nation by the end of the run on the Canadian ensembles takes us out through Saturday morning, September or November the 29th. And there we've got a big signal for cold air. So that's what we're wanting to see if we can have our druthers. And there is the snow anomaly map, very much like the other two. We want to see big snow being built out here, and eventually I think we will, but not right now. So that is the winter sort of outlook as we get on in toward the end of November and December. I would say kind of the big picture takeaway here is that we have several factors promoting or in favor of a fast start to winter in the east. We get into the first and second week of December, we really are going to see the stratosphere cooperating with us by getting weaker, the MJO potentially moving into a couple of good phases for us and just move slowly through those good phases through the month of December. And the cryosphere needs a little help. We need to get some snow up here in the cryosphere and Canada up around the Arctic Circle. We want to see more and more snow up here, at least in the land masses. Plenty of ice up there in the Arctic Ocean, but in any event, we want to see the snowpack build up and get deep, and keep that cryosphere charged up for us. And then the EPO looks like a ridge that it's going to develop. All the models are showing it. That's good news. And some blocking continues to show itself over the course of the next couple of weeks as well. Especially as we get into December, we should see that return as the stratosphere weakens. So that's good news as well. A lot of feathers in the cold winter cap, so to speak. And that's what we've got going on right now. But as we go through the next couple of weeks, look for mild temperatures in the central portion of the country, maybe into the southeast as well, and then start to see that gradual cooling process take hold. That's what I'm expecting, and December could be a very fun month. I know that took a lot of time, but hopefully it explains some of these things a little bit well. You're going to hear these a lot, and you need to know about them if you're following the weather as we go on through the fall and get into the winter season. We're going to talk about all of these indexes a lot, and that's that. Now we're going to wrap up with a quick look at the forecast for the next couple of days into the weekend and take a quick wrap up of the solar storm that we had. All right, we're going to bounce through this. All right, so we've got rain working into the west and snow showers and rain showers up here in the northeast this afternoon and evening. And as we go through the nighttime hours, not much will change. You'll still see some spotty rain and snow showers up in the northeast. Nation's midsection for most of the country is dry, and then more showers working in out west with places like Seattle and Portland just getting more and more rain. Look at this, LA down here into the LA basin and up into Nevada, the Colorado Plateau, places like that, Intermountain West. You guys are going to get some much needed rain, and this higher elevations are going to pick up some snow in the Sierra Nevadas, and then that energy will run into that ridge in the west and send a little low pressure system across that ridge and develop it and move it into the southeast as we head toward early next week. So the unsettled parts of the nation are going to be out west, maybe up in the Pacific Northwest as we head through the weekend. And as we get on into early portion of next week, look for Tennessee Valley into the southeast, picking up some potential rainfall. Temperatures very warm out west, very cool in the east to start our forecast. As we go into the weekend, that warm air is going to just move and surge eastward and get replaced by another push of chillier than normal air with a system coming in out the Pacific Northwest. You folks up in the Northeast look to hang on to those cool anomalies for a few more days, and then bam, by the time we get to Sunday, another system moving out of Canada will bring cold air in behind it and some clouds up there. But look at that ridge just hanging on here in the center portion of the country, keeping us warm through Monday morning with more storminess set to push in to the west by the time we get into early next week. Now that's that for the forecast. Let's take a look here at space weather and wrap things up. Not much going on right now. Fortunately, we have been in declining solar storm conditions. There is the sun, big coronal hole. It's kind of a bulk of it's toward the north, so it probably won't hit us too bad with a solar wind stream. And you can see the X-ray flux chart is just really, since that last big solar flare, it's just been quiet. Proton flux on its way down. We're not bombarded with protons as much anymore. And there is the big storm yesterday from that big CME. It was the biggest one of them all, but it didn't act like it. And because it was not charged the right way, it did not interfere or interact with the magnetosphere in as an extreme way as the one previous did that was charged differently. I'll tell you about that in a minute. But there's your KP index. Things are going back down. Things are starting to settle down. This is the solar wind speed and the density. The density was not is high for a prolonged period of time, and you get down here and look at this BZ signal. This is the charge of essentially the charge of the incoming solar storm. If it's charged negatively or in the southward direction of a southward polarity, then it's going to potentially engage with the magnetosphere in a more disruptive way. You get brighter auroras, you get a lot more displacement of the magnetosphere and bigger potential for electronic disruptions and things of that nature. Because it had a sort of a northward polarity, it largely was deflected, even though it was the bigger of the CMEs, the coronal mass ejections that were sent out toward us. That's why we didn't see G5 solar storms yesterday, and that's why we didn't see a lot of auroras as far south as we did, or at least as bright as it was. But everything's north now, looking good. The solar storm is abating, and so you just don't know. This is still a fairly new field to forecast in, so we just don't know sometimes how the magnetic field of the incoming solar storm or plasma stream will be. And so that's one of those things we have to wait and see. And so therefore, you've got a pretty good chance tonight to see aurora. We're still in those sort of solar storm conditions. So up here above and north of this line, particularly across portions of the northern United States, if you don't have clouds, go out and look for it tomorrow. Things should be really, really settled down. There's your sunspot map. There's some more coming around, but they're not here yet. These are all green, meaning they're very small, very non-complex and all of that. So that's what we've got, folks. That's our show for today. And I hope it's been informative for you. Again, long-range forecasting is, it's fraught with error and things can change. But when you start to see a lot of signals kind of line up and point the same direction, that increases your confidence. So the big takeaway is that December could be quite fun. Hopefully that it will be from a winter weather perspective. And that's all I've got for you today. I'll be back with a normal show tomorrow. Anyway, I hope you have a wonderful day. Thanks for sticking with me. And as always, take care and God bless.